Hi class, so this is going to be a presentation on the unit circle and some uses for it in different areas of math and science. So we have here just a picture of the unit circle, and on this unit circle we have all of the degree measurements here on the inside, and then a little farther out we have all the radian measurements, and then on the very outside of the circle we have the points as if you were to plot this on a regular XY axis graph. So here's a picture of the unit circle with just the degrees on it, and as you can see we start over here with 0 degrees, and then the most important measurements are broken up into increments of 30 degrees. We have 30, 60, and 90, and then so forth, and then the other important increment is broken up into 45 degrees. We have 45 degrees, 90 degrees, 135, and so forth. So you can see here that we start at 0 degrees, and then on the other side of the circle a straight line is 180 degrees, as we know, and then we get all the way back to the other side of the circle again. We get back to 0 degrees, and that is also equal to 360 degrees. Here we have a picture of the unit circle with just the radians on it, and the radian measurements are a little bit different than degree measurements because radian measurements are in relation to pi. So here we start with 0 radians on the beginning of the circle, and then we go all the way to over to the other half of the circle, and we have pi, and that's just 1 pi. So then we have the top of the circle is 1 pi, and the bottom of the circle is 1 pi. So then when we get to the end here, 0 is also equal to 2 pi. And then you can see the different measurements are broken up by dividing pi by the fraction that would be equal to that degree. So we have pi over 6 here because this is pi divided by 1/6, and then at the top of the circle we have pi divided by 2 because this is 1/2 of the top of the circle, and again the top of the circle is just pi, so we'll get pi over 2, and that is the same measurements for the rest of the circle. You can get the rest of the measurements by doing those similar fractions. So here, this unit circle just has the measurements for all of the degree and radian measurements. And so we start with 1, 0 because the unit circle, the whole point of the unit circle is that the radius all around the whole unit circle is 1. So right at the beginning here, we have radius 1, and that's our x-axis, and then along our y-axis, it's just 0. And then moving along the unit circle, as we go up, this y measurement is going to be 1/2 because if we slide on over here, we can see that this is approximately 1/2 the distance up the y-axis, and then your x measurement is going to be √3/2 because if we go down, if we derived this all out, we would find that this measurement is approximately √3/2, and we can see that that's going to be approximately correct here because that is a little bit over 1/2, and that's right about where we are here. And then if we keep going up, we have √2/2, comma √2/2, and you can tell here that this point plotted here is approximately the same distance along each axis, so those points are going to be equal always at your 45 increment degrees over there and over there as well, and then on your 2 bottom quadrants. And then moving up, we have the opposite of our first point here, because along our x-axis, our first point here, we go down and we can see that's about 1/2 of the distance of our x point, and then we go across and we can see that this one is also at √3/2, and then moving up to the top here we see that along our x-axis we have 0, and then our y-axis we go up 1 because our radius is still 1 here. And then the most important thing for the unit circle is to just memorize this first quadrant, and then once you know that, you can just move along the circle and apply negatives where they are needed. So for example, in the second quadrant, your x-axis will always be negative, so your x points are just going to be negatives of what they were in the first part, and same for the bottom quadrants, you just apply the negatives where they are needed. So now we're going to talk about some uses for the unit circle in math. So it is just helpful to memorize these values because they show up often in all areas of math and science. And another reason that we need to know the unit circle is because we know that the values of sine and cosine can never be more or less than 1, and this is because of the unit circle and our knowledge of the unit circle. And so the reason that is because if we look at the unit circle here, our radius is 1, and that's along our x-axis and our y-axis. So the greatest value you can ever have for cosine or sine of 0 is 1. So if we have cosine of 0, then this is your 0 point, and then the cosine of this is 1 because that is your point out here, and then the sine of 0 is your y point, and that's also 1, and it can never be greater than 1. So that is useful information when we're talking about limits and different values for math. And then another important use for the unit circle is because if we were to do the derivation of it, we would find that cosine of theta squared plus sine theta squared equals 1. But the reason that we know that is true is because of the unit circle, and we know that because of the Pythagorean theorem. So here we have our cosine theta, which is our x value right here, and then that squared plus our sine theta, which is our y value here, squared equals 1, because we know from the Pythagorean theorem that x squared plus y squared equals your hypotenuse squared, and our hypotenuse in the unit circle is always going to be 1 because our radius is 1. So this is all I have for you guys on the unit circle today, and we will talk more about this next time we meet. Thank you, class.